Hello students, myself Biswajit Chakraborty, Assistant Professor of SRIST College, Mechanical Department. Today we will discuss about the fundamentals of thermodynamics of thermal engineering 1. First of all, we should clear one thing, what is thermodynamics? Thermodynamics is that branch of physical science which deals with the various properties of gaseous fluids related to production and regulation of heat energy. Now, what is thermal engineering? The field of engineering science which deals with the application of thermodynamics and its laws to work producing and work absorbing devices. Here, three important terms shown in the figure: system, boundary, and surroundings. Now, what is system? In thermodynamics, system means matter content in a region. Here matter means fluid. Boundary means a wall which separates system from the outside surroundings. Classification of systems: 1. Closed systems, 2. Open system, 3. Isolated system. We need to understand the difference between these three classifications very clearly. In closed system, the boundary is closed so that mass within the boundary remains constant, but energy transfer may take place across the boundary. A closed system is shown in figure. The gas in the cylinder is considered as system. If heat is supplied to the cylinder from external sources, the temperature of the gas will increases and piston will rise. As piston rises, the boundary of the system moves. In other words, the heat and work energy crosses the boundary of the system during this process. But there is no addition or loss of original mass of the working substance, which compromise the system is fixed. Thus, a closed system does not permit any mass transfer across its boundary, but it permits transfer of energy, that is heat and work. Number 2, open system. In open system, boundary is not closed but has one or more openings through which mass transfer may take place to or from the system. In open system, there is also transfer of energy across the boundary. Here, figure shows an air compressor, which illustrates an open system. The working substance crosses the boundary of the system as low pressure, that is LP. Air enters the compressor and leaves the high pressure HP air. The work crosses the boundary of the system through the driving shaft and heat transferred across the boundary from cylinder walls. Thus, an open system permits both the mass and energy, that is heat and work, transfer across the boundary and the mass within the system may not be constant. Third one, isolated system. In isolated system, there is neither transfer of mass nor transfer of energy through the boundary. Hence, isolated system is not influenced by surroundings. Universe is the example of isolated system because in the system there cannot be transfer of any mass nor cannot be transfer of any energy. Properties of system. The physical quantities in terms of which the behavior of a fluid can be explained are called its properties. Examples: pressure, volume, temperature, etc. are some of the properties of a fluid. Properties may be of two types: intensive properties and extensive properties. Properties which are independent of mass are called intensive properties. For example, temperature, pressure, etc. Properties which depend upon mass of a fluid are called extensive properties. For example, density, energy, etc. State of system or state. The condition of a system at any given instant as described by its physical properties is called state of the system. State denotes the various or values of properties of a system at the given instant. Change of state in a particular time interval can be found out from the properties at the beginning and at the end of the time interval. Here in PV diagram as shown in the figure, 1, 2 are the states of the system. Process. In thermodynamics, process means series of states followed by a working medium, that is gas, liquid, etc. as it receives or transfers energy. As shown in figure, 1 to 2, 2 to 1 are the processes. When a working fluid returns to its initial state after performing series of processes, then it is said to execute a cycle. Here in PV diagram, 1A to B1 is the cycle of the system. Flow process and non-flow process. Processes undergone by a fluid in open system are called flow process. So in flow process, there is a continuous flow of a fluid from one region to another. Processes undergone by a fluid in a closed system are called non-flow processes. So in non-flow process, there is no continuous flow of a fluid from one region to another. Work. Work is said to be done by a force when that force acting on a body moves the body through some distance. So work is equal to F into S or F into X, where F is equal to force acting on the body, S or X displacement of the body. In SI units, F is usually measured in Newton and distance is usually measured in meter. In that case, unit of work will be Newton meter or joule. Heat. The heat is defined as the energy transferred without transfer of mass across the boundary of a system because of a temperature difference between a system and surroundings. It is usually represented by Q. What is the difference between heat and work? Heat is the random motion of molecules, while work is the ordered motion in one direction. It can be proven that work can be totally converted to heat, but heat cannot be 100% converted to work. Heat is a function of state, while work is a function of path. Heat is a form of energy, while work is a method of transforming energy. Energy. Energy is the capacity for doing work. Unit of energy is the same as that of work. So units of energy are joule, kilojoule, etc. There are two types of energy. One, stored energy. Two, transit energy. Stored energy. The stored energy is that energy possessed by a system within its boundaries. Example, potential energy, kinetic energy, and internal energy. What is transit energy? The transit energy is the energy processed by a system which is capable of crossing its boundaries. That is heat, work, electrical energy. Kinetic energy. It is energy processed by a body or a system for doing work by virtue of its mass and velocity of motion. As we all of know, what is kinetic energy? Half into mv square, where m is equal to mass of the body, v is equal to velocity of the body. Unit Newton meter. What is internal energy? It is energy processed by a body or system due to its molecular arrangement and motion of the molecules. It is usually represented by capital U. Another important term, enthalpy. In thermodynamics, one of the basic quantities most frequently recurring is the sum of internal energy and product of pressure and volume. The sum is known as enthalpy. In mathematically represented as H is equal to capital U into P into V. For unit mass, specific enthalpy, small h is equal to U plus capital P Vs. U specific internal energy, Vs specific volume. Unit in SI, joule. Thank you very much.